Welcome. Please find your seats. So I want to welcome everybody to the UC Center in Sacramento. My name is Alex Bayen. I'm a professor of electrical engineering and computer science and civil and environmental engineering at UC Berkeley. I'm also the director of the Transportation Initiative at Lawrence Berkeley National Lab and the director of the Institute of Transportation Studies at UC Berkeley. I'm going to just give a quick introduction about the context of this meeting and explain a bit how we're going to proceed and then introduce the speakers. So the Institute of Transportation Studies is an institute within 4 campuses of the UC system. It was created in 1947 with a Berkeley branch. It has 4 main missions, which are research, teaching. We have transportation curriculum, tech transfer, which is an outreach arm, and a library, which works on digital records. Since its inception in 1947, it has extended greatly with the creation of 3 additional branches, Irvine, Davis, and UCLA. And I want to acknowledge the presence of the director of the Davis branch, Dan Sperling, who is here on my left. Part of our mission as the Institute of Transportation Studies is to support the state of California in as many questions as we have expertise in the field of transportation. And so what you will see today as part of this forum is one of the many outcomes of the work we do for the state. As you know, it's really important for us to work as a team, and so across the 4 branches, we really try to dispatch the work based on the core competencies of each of the branches. Other states, in particular Michigan and Texas, are very active in this field, and we want to make sure that California also is in a leadership position for this. And so the typical thing that we do on behalf and for the state are legislative briefings, policy forum series like this one. There will be 2 more, and you can grab a program on your way out, or you might have grabbed one when you came here. There's policy briefs that come with it on very specific questions that are of interest to California. And we also do a lot of on-demand work directly for the state that is defined through a board of all the ITS branches that funnels and channels to us the specific interest that we need to work for the state. Now, specific to this policy gathering and this forum today, you can see a lot of buzzwords on the title, but the truth is they all make a lot of sense and have a lot of importance in the context of transportation, big data, smart cities, the Internet of Things, and networks. And so I think one of the things that we are very concerned about, very excited, but also very concerned about, is the explosion of data, which has had massive influence on the transportation landscape over the last decade, and we really see things accelerating. So I think part of the goal of the forum today is to try to do a bit of a walkthrough of all the changes we see and all the implication it has with equity, with policy, and many other things. So just in your daily life, if you think about, for example, GPS data, 10 years ago, very few people had a smartphone with a GPS. Today, probably everybody in this room, or nearly everybody in this room, has a phone with a GPS. This has created massive amounts of information, which over the last couple of years have transformed traffic guidance system and routing systems. If you think about cell tower records or cellular data, single providers in California have up to 40% of the population using their network, which means if you're a planner and you're working on a traditional 4-step model, this data, should you have access to it, could enable you to do planning and forecast like not possible before. Social network data is another one which enables to do great things. Some public transit or train information systems are sometimes less reliable than Twitter feeds just because of the instantaneity of the network. So there's many, many such examples. And so when you look at this, on one end, data provides enormous opportunities to the transportation world, which is why a lot of us are here today and excited about it. But at the same time, it also provides a lot of challenges. And these challenges ranges from ownership. Who owns the data? Do you own your data? Does a third party own that data? Obviously, privacy is another big concern with that data. The data provides a lot of value, but that data also contains a lot of information about your life. And so what you will hear about today is, how can we factor in through all of these different aspects of the data that provide great opportunity, but also great risks through the ownership aspects, the privacy aspects, the processing aspects, the cleaning of the data aspect, the machine learning, which has enabled a lot of different applications, and ultimately the architecture and the infrastructure on how to collect that data. So the way the briefing will proceed today is we will have two speakers who will do a short presentation on the topics that are relevant for these problems, and then we'll have a respondent who will respond and engage the speakers on the themes that they presented. And in the last 10 minutes of the meeting, we will open this to Q&A to the audience so that you can engage the speakers. I'm going to do now is I'm going to introduce the speakers. What we will do is we'll really keep the questions for the end. I think a lot of people here are on their lunch break, so I have probably a 1 o'clock sharp. So we're going to keep the questions for the end for the Q&A. That way we can stay on schedule. Okay, so let me introduce the speakers. Our first speaker today will be Jane McFarlane. Jane is the Executive Director of the Sustainable Transportation Initiative at the Lawrence Berkeley National Lab. She has 30 years of experience in high-performance computing, data analytics, and geospatial data. She was the head of research for HERE, former Navtech Nokia, and before that, the vice president of engineering at IMRA, and before that, the director of advanced technology planning for OnStar. So a lot of long-standing experience in the field of big data, specific to the context of transportation. And she holds a PhD in mechanical engineering from the University of Minnesota. Our second speaker today would be Professor Alexey Pozdnukhov, who is currently on the faculty at UC Berkeley in the Civil and Environmental Engineering Department. Alexey graduated from the Department of Physics in Moscow State University. Following this degree, he received a PhD in computer science from EPFL in Switzerland. And before joining Berkeley on the faculty, he was part of the National Center for Geocomputation at the National University of Ireland. He's joined the faculty a few years ago and is currently the chair of the Smart Cities program within the Civil Engineering Department at UC Berkeley. And our respondent for the forum will be Brian Brennan, who is the Senior Vice President at the Silicon Valley Leadership Group, where he's been working on various problems that handle local planning decisions and changes in mobility patterns. Obviously, I think Silicon Valley is really the perfect testing ground for a lot of the work that we'll be discussing today. And so before that, he was working for the US Agency for International Development in Russia, where he served on international affairs, and he holds a PhD in comparative government from Oxford and related degrees from Stanford University and Princeton. So with this, I would like you to join me in welcoming our first speaker today, Dr. Jane McFarlane.
Thank you, Alex. Welcome, everybody, and thanks for being here. Let me find my presentation. Well, it's a pleasure to be here. And I thought I'd start out with, you've all heard the phrase, may you live in interesting times. The actual source of that actually came from a British politician in the time of Winston Churchill. And what came behind it was, and let me say also, new objects for anxiety. And I believe that that fits quite well for transportation right now because there's a lot going on, and we are definitely in a transformation, a very dramatic transformation. And so the question is, what's causing this transformation? Alex kind of touched on it earlier. We have a confluence of technologies that has us on a hockey stick kind of growth path due to the technology. So we've got the Internet of Things that's giving us local activity, geospatial temporal data at massive rates, 1 second sampling rates on vehicles, for example. And that's giving us this activity profile. And then we have big data that's allowing us to model things, discover things, and eventually predict things. So that also is happening. It's also, by the way, a giant resource hog. And so there's a lot of data out there, a lot of it redundant and very costly to keep. But what's really changing now is we've got networks. When I was at OnStar, the vehicle data was locked in the car because we had no bandwidth. The bandwidth is there now. So things are really going to dramatically change. So what this does now is it gives us just rich data. And what you see here, the resolution is not good on the screen, but this is Atlanta. These are cell phone traces colored by speed. So you can see how rich this data is. You can see that the blue is high speed. So you can see the ring road around Atlanta. In the center there is downtown. But Boston looks completely different. You've got a half a ring road. So, and then go to San Francisco, very different structure. So you can see how this data can inform us about how cities are served, for example. Vehicle data. This is vehicle data that was collected in Ann Arbor, Michigan, visualized, showing braking patterns as people come up to an intersection. You can see the blue on the main freeway where you see them braking as people are entering the freeway. So we're starting to really understand how people actually behave on the roadways now. And imagine how useful that could be for automated vehicles as we move forward, because we'll learn how people actually experience driving. Now, what's happening also is, as Alex mentioned, we're generating the data, you and I. So we've got now the citizens interacting with social systems through technology. And there are many that consider this kind of the fourth industrial revolution, because we are changing as human beings how we operate based on these devices we're carrying around with us. Our smartphone is always in our purse or our pocket. And we are now not really even using it for phone calls anymore. It's our advisor. It's telling us how to take the bus to work, what the best way is to get to work. So these devices are becoming part of how we engage. And as we all know, technology can accelerate things for the good or for the bad. So we have, GoFundMe campaigns that help families, and then we have cyberbullying, all from social systems. So this technology can go either way. In addition, I had to chuckle when I saw this infographic on the web. This is a VC trying to get their arms around the Internet of Things. And it's dizzying. There's so much activity. And the comments below it on the webpage was, well, you forgot so-and-so, and you forgot so-and-so in this picture. So it gives you a sense of the investment that's happening in this. In just automated vehicles, this is an infographic of how people are funding technology in automated vehicles. Uber and Lyft are delivering billions of people to their destinations. Smartphone apps are moving everybody in the Bay Area or in Sacramento. These smartphone apps are managing our traffic from the bottom up. So it's a bottom-up transformation that's happening by virtue of this technology rolling out into the population. Now I'm going to take a little sidestep to this, being that I was originally at OnStar, and that is our fatalities are going up. When I was at OnStar, I started out my talks with there are 42,000 fatalities on the road. That was in the late 90s. The OEMs have improved the vehicles, and our fatalities went down to 30. And now they're back up last year to 40,000. It's very sobering and very disturbing. I think it's because these things that we're doing are coming into the car with us. And something that we have to remind ourselves is the vehicle is not a consumer device. It is a weapon. It's truly a weapon. And I'm sorry to be the Debbie Downer, but you may have recently heard of this crash in Texas where 13 people died. And the young man that was driving was texting. And that's very, very sad that this is happening and there's a serious change afoot. So, out of the Debbie Downer side into the solution set. So these solutions are coming bottom up. And we need to meet that with top-down thinking. So, for example, there's a smart mobility program being sponsored by DOE that is trying to assemble interdisciplinary teams to address the next generation traffic management and this transformation that's happening. We don't have time to go into it today, but please come and speak to me if you're interested in it. Alexey is going to talk today about using machine learning to understand activity patterns, mobility patterns. We need the mobility patterns in order to get the requirements of what the transportation system needs to look like. We can do things with this big data. This is the city of Eindhoven. This is where people hang out. This is where they congregate. It tells us a lot about the dynamics of the city. We have activities going on in Los Angeles now. If you haven't heard about it, is the Connected Corridors project. Kudos to Caltrans for implementing this, where they are sensorizing a full corridor down on the I-210, so that we can start to understand how to manage disbursement of traffic in a corridor when an event occurs, for example, and what the dynamics look like. It's a very interesting project. We need that in order to control and optimize mobility from the top down instead of the bottom up. And not being done here, but it is being done in Dubai, is aerial taxis. This is a one-person drone that goes from station to station. So it's coming. Now we have to think of mobility in yet another dimension. So, so truly multimodal, I should say. I'd like to kind of share a thought about in my oversimplified world. I've worked in industry and in the labs. I think about kind of there's three categories of people. There's the entrepreneur that says, give me some money and I'll get it done. Then we have the CEO that says, oh my gosh, there's a wave of technology happening. I have to be a part of it. Please tell me it will work because I'm investing tons of money. And then we've got the third category is researchers. And what we do as researchers by nature is we say, what are the edges of the technology? When will it not work? And as we get into automated vehicles and the like, we have to keep asking that question. The Tesla event in Florida was because they hit the edge of the technology. And my claim here, you saw all that investment by the VC community, is that scale is a little bit tipped. There's a huge amount of money in the entrepreneurial side, and we need to balance it out with the research side, so that we are, in fact, doing responsible science with ethical best practices, and that we keep reminding ourselves that these vehicles are not consumer devices. So I'll end that with stating, yes, we are living in interesting times. It's very exciting as we go forward, and I hope that we go forward with the appropriate care, that we don't kill people on our way, and that we don't create a dystopia of emissions and every piece of our pavement covered. So thank you for your attention, and I will pass it on to Alex to introduce Alexey, I guess. Or Alexey, you want to just jump up? Thank you for your attention.
Good afternoon. So I will talk about a more concrete application of what can be done with big data and put it into a context of particular application in travel demand forecasting. Some of this work been done by Berkeley and Lawrence Berkeley National Lab, and most of this work was funded by Caltrans. So this is what I wanted to talk about. What is the added value of big data in travel demand forecasting? How can we change practices of building activity-based travel demand models? And what else can we do? And what else should we be doing with this data? And what it all means? Can it actually change everything? The big data we're working with, when we started this work, we were mainly working with cellular data. This is the data collected by the operators, and it's nothing that's been logged on your phone. It's something that's been passively sensed on the side of the operator. The cell phone towers communicate with all the devices they serve, and every communication has been logged. So you don't even need to install anything on your phone, and already you're contributing to this big data collection from multiple industry parties. So what it results into is that every mobile device has been tracked to a certain accuracy. And this accuracy varies, and it's a good thing. It's a bad thing for some application, but it's a really good thing for privacy. I think there will be more regulation about what the localization accuracy should be in every login event. And for us, it means that this accuracy is variable, but it's good enough for at least applications in planning and applications where we have to deal with urban decision-making at the scales of hundreds of meters, a few hundreds of meters. And what big data brings in these applications, well, you just get better data on everything you wanted to know, but you couldn't collect the data about. Better data on where people are, first of all. Within this level of accuracy, you can clearly see every change that is happening in any region where you've got the data being collected. You could see how many people are now there in these new developments in the East Bay. You could see what happened with the job markets. If you cannot explain a pattern of traffic volumes on the Dumbarton Bridge that crosses the bay over here, all right? You could see it in the data. It happens because the companies in the Silicon Valley just hired 2 times more people than before. And your travel survey been conducted before they have done that. And with the data you collect every day from telecom operators, you can see change instantly. And this is a very good thing. So spatial resolution of conventional big data sources is becoming useful. Also, the temporal resolution is becoming really, really good. So here what I'm showing is I took a certain region in the East Bay, and I'm looking at all the events of departures and arrivals that I have identified as little trips, all sensed anonymously from the cellular data. What you could see here is, well, this is one certain day in June, and this is another certain day in June. They are both weekdays, and there's a little gap over here in the evening. Right? There are less people, so everything just stalls for a moment, for 2 hours. And sometimes you see the same things on weekends. This is a typical weekend, and this is another weekend, and everything again comes to stall for a few hours in the evening. What is the difference between these days? Well, that was the days of the finals. Everything just stops moving. People just watch games. And you can see things with this resolution in time and space, and that's really useful. You could see how particular obstructions on the road, such as roadworks or temporal closures, how they influence the traveling population. Who is influenced? Where you would expect people to get delayed in their destinations, because you know where they're going and you know their routes. So there's much more things that we can simply measure. This is the first big change that is coming. Second thing, we can build much better models. Since we can measure things better, we can build much better models that will explain and forecast all these things that we can measure. We can start looking into sequences of activities of individuals and extracting their typical or maybe atypical lifestyles and patterns of mobility, decision-making, choices, and so on. We could start looking into long periods of data, of observation, and trying to understand for every user of a cellular device, where is the home, where is the work, what else is going on, what other activities are happening, and when, and where, and why, even why. You could start answering questions like this. So with our recent work, we basically built some machine learning models to understand what other activities people engage in, when and why. And the way it happens is that we build this models such that they're transparent enough to give you very useful conclusions. For example, I can show you what we can infer for a particular individual that the model has been trained on. And this pattern over here shows us how long will the home stay will be for this person, depending on the arrival hour to home. So you could see that it's a probabilistic model, because when you observe somebody arriving home, there's a slight chance that the person will stay for an hour. There's much higher chance that the person will stay for almost 15 hours. And the later you arrive home, the less time you've got to stay because you have to transition to work in the morning. Okay? If we observe this person transition into work and been at work, it's very likely that that will be at 9 a.m. and this work activity will last for 9 hours. But it's also a little bit likely that this guy will work for half a day starting in the morning, or for half a day starting in the afternoon. And another interesting observation. Look, this guy is actually a little bit lazy, in the sense that the later you arrive to work, the less the duration of your stay will be. You see, there's a negative correlation here. There's a little slope in this distribution, and then this one. The later you arrive, so this particular guy will just try to depart by the end of the workday, not stay in the hours. And you can do this kind of inferences. You can do way more. We complicated these things up to the level that they're becoming less useful. So we have to stop complicating things. But what it all ended up with is this pretty nice simulation projects that we implemented with the funding from Caltrans and support from AT&T, where we took the AT&T data set of the users, aggregated and anonymized, and we learned these models for the population of the users. We upscaled them to the total population of the Bay Area, and we feed them into a micro simulation of travel. So you could start looking into how a typical day in the Bay Area looks like. It's useful. It's really useful. And also now we of course we validated it on the traffic counts, and the fit is reasonable, and it looks pretty good. So I believe that technologies like this will, first of all, decrease the costs and decrease the latencies in the time of building and running travel demand models. What else? Well, we can forecast things much better, because look, if I know that my particular user is at home right now, I know how long it's going to be at home. So I know that this day will start with a sequence of home activities. The moment I observe travel, well, it will most likely be travel to work. If I see that the work activity has started, well, it will continue. And most likely it will continue for the full day. We got all these distributions, we know that. Then it will switch. It will probably switch to some shopping activity, more travel, and way back home. And while I observe a day, how the day goes, I'm better and better in predicting how the day will conclude. So we can forecast by observing the first half of the day what's going to happen on the next half of the day. And with that knowledge, we can also optimize the travel systems. If you want to minimize the travel time for everybody, it really helps knowing where they're going and when they're going to depart. You can start thinking about interventions. You can start thinking about network optimizations and many other things. Okay, to conclude, can big data change everything? Certain things, for sure. First of all, and the first big change that is transparent, but I don't think that people realize it. First of all, most of the travel impact metrics becomes precisely measurable. The data on VMTs of level of service, on all the metrics you need for before-after analysis for every planning and development project, they will not be coming from models, not from consultants, not from contractors, real estate developers. No, they will be just measured precisely. It will be a big change. The second thing is that this bar for accuracy on travel demand models will be set very, very high. There's no excuse of not being precise, having all this data. There'd be no excuse for travel demand forecaster to say, oh, sorry, there was no data on this. The models are bad. No, we are over that. So these two big changes, I think, are coming. And thanks very much.
So I hope that with these two talks, you had an opportunity to at least see, with the first talk, the genesis of the data, how we got where we are today, and how the data is created. With the second talk, more of a deep dive into one of the many things that you can do with this data, and hopefully after this talk you realize that we've just scratched the surface. So that's a perfect segue into respondent. And maybe the one thing that I'd like to start this with, we're going to have Bayen try to respond to these two things, is obviously Silicon Valley is at the middle of it. Because if you look in terms of the data production, we heard GPS, we heard cold data records, we heard a little bit about social network data. I mean, the vast majority of that data is produced by firms who are here in the Bay Area. At the same time, there's two main hurdles or two main obstacles in trying to achieve the vision we've heard here. One is, I mean, how would that data be shared? I mean, it would be amazing if public agencies had access to that data, but this has not happened today, so we need to probably think about ways that data can be shared. And then maybe the second part is Silicon Valley is part of the problem and part of the solution. In a sense, it's currently suffering from its own asphyxiation by traffic. The level of economic activity, and we saw that in the beautiful graphs of Alexey, in a sense have made that even worse. So how can the ecosystem of the Silicon Valley engage in fixing that problem, and not just locally? Obviously, this is happening all over the world. So with this, Bayen, I'd like to invite Bayen to respond either at the podium or here for about 10 minutes, and after that, we'll open this to the audience for Q&A.
Would you like me to come up there?
Whatever you're more comfortable with.
Great, thank you. Well, thank you very much. This is my first time being in a forum of this sort, so it's a real honor to be here with you. Before I start, I'd like to get a sense of the audience, if I may. How many of you are state employees? How many of you are students? Anybody from industry? Okay, great. That gives me a good sense of things. And Alex, I'll try to touch on your questions. But what I wanted to do, and I want to give Jane and Alexey a little heads up, is I wanted to engage a little bit through questions about timelines for the penetration of some of the technologies that you talked about, and policy implications of those as well. What I want to do for start is just give a sense of kind of the perspective that I bring to this. As Alex said, I'm with the Silicon Valley Leadership Group, so we're a trade association, about 350 companies from Silicon Valley. Most of the big dogs are brand names you know, and many mid-sized and smaller companies as well. And as we have looked at the various technological revolutions that are going on right now, there are three main things that the folks in the Valley with whom I speak think about. The one are the technological hurdles that they're facing, whether it's in terms of big data or sensors and mobility more broadly, whatever that might be. The second is business models. Which business models are going to emerge triumphant, or how will they interact when you're talking about mobility? Certainly that's true with respect to autonomous vehicles, whether they be personally owned or a mobility on demand model. And then the third is consumer behavior. What are consumers going to do? Because that's a big question, and nobody really knows. When we talk about these issues with a policy audience, the questions are totally different. A first question is, what does this mean for dynamics around labor? A second question is, what does this mean for dynamics around climate and emissions? What does this mean for social justice issues and equality? And what does this mean around safety issues? So I illustrate that, or I speak to that, to emphasize what is really a very different worldview that exists here in Sacramento and in Silicon Valley, and one that fundamentally we really need to work hard to bridge, because both parties need each other in a very big way. My organization actually just led a sales tax measure in Santa Clara County because transportation is so bad there. We are actually among the tech hubs in the United States. We are actually the second worst in terms of average commute time, behind New York City. An hour and 10 minutes is the average time people spend in their commutes in Silicon Valley. And it's actually getting worse. So we're gaining on New York City. Interestingly enough, the answer that we had was very conventional. It was fixing roads. It was extending BART down to San Jose. It was electrifying Caltrain, there wasn't really a whole lot of thought to some of the advances in transportation that we're going to be seeing over time. And why? Because we don't really know what it looks like. I mean, we kind of know. But some of the dynamics that Jane and Alexey talked about, the big question that we're always asked is, well, when? Chris Urmson from Google commented on that, and he says, some people say that we're going to be experiencing a mobility revolution in the next 3 to 5 years, and other folks say it's going to be the next 3 to 5 decades. And his answer there is, well, it's probably both, depending on what you're talking about, and depending on where you're talking about it. So that I'd love to ask Jane and Alexey, in terms of sort of this precision data, Alexey, that you were talking about, what will that mean in terms of deployment? What does a timeline look like? Let's say specifically, either specifically in California, maybe specifically even in the Bay Area, just to localize it a bit. And then what does that mean for people's experiences and policymakers? And Jane, the same thing, in terms of sort of the changes in mobility that we're going to be experiencing, and that intersection with IoT and big data. What types of changes are we looking at in the next 3 to 5 years, and what does that mean for people who are charged with making decisions about public resources and about how folks are going to get around?
Sure. So what I think about this dynamics is, innovation in the consumer technology is very different from trying to innovate in technology or sector that is concerned with public sector. First of all, it's just way slower, and it will be slow, and that's good. There are natural and very good causes for that. It's good that public sector is slower responding slowly to these changes, because there's time to think, and there is time to talk to researchers, there's time to talk to academia, and I think this dialogue has to be more intensive. And the second reason why things will go slower than expected, industry started to set up certain standards. Coming to your exact question about the Bay Area, how long things will change, how long will it take for things to change? Quite long. Because the data like this is really sensitive. The internal privacy review in every reasonable company will take years until products like this will appear and hit the market. There's no research. There's not enough research on privacy. There's not enough research on social implications on privacy, and company will really move slowly. It's very easy to show examples like this, to deploy things like this without a company, with the company being sure that privacy of the users is protected. It's a different thing. I think these expectations that things will just change drastically just now, they are a little optimistic. It will take 5 to 8 years to do things like I described, but on the practical side.
Mm-hmm. Are there things that policymakers need to be doing right now, or is it rather, well, we've got some time to wait and see as these technologies develop, and then we'll have a better sense of how the public sector needs to be engaged?
I think that the standards for evaluating accuracy of models and predictions, especially in travel demand forecasting, has to be changed. I think we need to start thinking about setting up new standards. It's overinflated forecasts for all the projects. That's a disaster, and it must end.
Thank you. Jane, what about you? Timeline, policy questions?
Yeah, well, first of all, I want to just talk about big data, right? So you've seen some of the big data that we showed, and it's way bigger than it needs to be, because we're, again, doing everything from the bottom up, because we can collect at 1 second intervals, so we do. And so then we take all that data and we pump it up to the cloud, and then we have to use big data tools to get some mine information out of it, right? So we're already doing it kind of wrong, right? And secondly, most of that data is behind corporate firewalls. So us as researchers and public do not have access to it. So there's some things that need to change from that perspective. We need to understand how to build win-win situations with the people that have the data. And they have data that is not relevant to their business model. That could be, what I say is one person's exhaust, data exhaust, is another person's gold. Just put your hand under there and you'll catch all kinds of gold. And they really don't care about the data. So there's a lot I think we can talk about together to really understand how to mine this data and get the best use out of it. As far as, kind of when the technologies will come, we need this bottom-up, top-down kind of solution so that we can kind of manage that process so that it doesn't go too fast in one direction and we end up with a dystopia instead of a utopia. So we really do need to, start doing that top-down thinking and not let startups and smartphones define our future. So, there's a lot of really interesting work to be done. And that data is amazingly rich. It's just how do we service all the people who need it?
Throw the question back at Bayen. So this data exhaust, I think, is very appealing because you look at companies like Sidewalk Labs or even the partnerships with specific routing service providers. How does that, in a sense, you could argue that Silicon Valley is sitting on a potential solution to its own problem, rather than you saying like building new roads. What is your perspective on this, Bayen?
So the incentive structures are completely screwed up in order to see that happen, because companies have absolutely no incentive to share these data. They're very concerned about the integrity of the data, the safety of it. They're sort of getting battered from all directions on this, and so there's ironically in this context there's a real risk aversion involved. What type of it sounds funny to say, but companies need protections from the threats that they see from making these data available, because the safest route for them is not to. They use their data as it's most useful to them, and then they put the rest aside, because anything else is just trouble. I mean, that sort of from a corporate perspective, that's just the reality. And so finding a way to create a new incentive structure, or a new structure, a new governmental structure that can manage that. I mean, that's a big challenge. It's a huge question, though. We're not equipped to answer it now.
Very good. So maybe Jane and Alexey, if you had a 30 seconds concluding statement before we open the forum to questions to our two panelists and respondent. Jane, do you want to start maybe?
Yeah, I guess I still want to raise the big data flag if you haven't been involved in big data analytics. And when I worked for HERE, which is a mapping company, I spent 5 years digging around in that cell phone data that I showed you, and it's a black hole for your money. And so it's really, it takes a lot of time, and it's not easy to get to the rich, important information. So I think that's the one message I want everyone to take. It is rich data, but we have to do it better. We have to really think about how we collect it and what we do with it and what it's for before we collect it.
I would like to conclude that I think the whole field of making inferences from data and applying them to policy, I think this whole process has to be way more transparent. All the results have to be reproducible, and this is the standard academic practices of making science useful has to be just transferred to industry, to public sector, to make this process way more open than it is now, because it is a big call, of building algorithms and trying to extract inferences. But if this process is hidden from decision makers, if you don't know how these conclusions been made, they're not useful to you. Don't trust them. So I think together with these complications for companies, the companies have to start thinking about making processes more transparent. The regulators must actually enforce some of these processes to be transparent, and then I think we'll change the field and direct it towards being really useful.
Brian?
I will cede my time for questions. Other than say, it's an honor to be on the panel with you two.
Very good. So we're going to now move to the last segment of this forum, and again, being very mindful that probably a lot of you are on your lunch break, so we'll try to end up by 1 sharp. So we'll have a mic. Laura Melendi, the Assistant Director of ITS Berkeley, will be passing the mic. When you ask a question, we would be grateful if you could tell your name and the organization you represent, and then ask the brief question. So the floor is now open to question to our panelists for whoever is interested.
My name is Jeff Tartagia, and I'm an advocate and always interested in information. Now, I've also had the opportunity of working for Dun & Bradstreet, so I understand collecting of data in a certain sequence and parameters. So 2 questions I have is one, is there a commonality of languages that's being used in the collection of the information? And have you ever considered, like Dun & Bradstreet doing with a number of parameters that they look at, of what is a process or procedure of collecting the relevant information?
So,
Is that too big? Or
no, it's so as far as, first I wanted to point out that, for example, the here data that I showed on the screen there, that is sourced from many different places, which is a challenge all unto itself because everybody is doing something different. And you don't know what kind of GPS device is on the device that's giving you data. So just even data quality is a huge problem. So people are just collecting stuff everywhere right now. It's kind of a random, everybody's collecting what they can. And what's interesting also is it implies biases in your data that can really kind of change the outcome of the thinking from the data. So the answer is no. There's, everybody's collecting it differently for different purposes. And it's time that we took a step back and said, all the modeling and things that the inferencing that we do from it, all depends on that input data. And so there's a whole body of work yet to be done on what to collect, how to collect, what bias is in it, how do we manage quality, how do we manage provenance. There's just a huge body of information or research yet to be done on how to make that Internet of Things really turn into something useful for us.
Very good. Before the next question, I want to acknowledge the presence of Senator Bell here. We're very honored to have you, and we're very grateful for your strong support to the transportation agenda in California and for the work we do. Thank you. We'll move on to the next question.
Yes, Ted Link-Oberstar with the Senate Office of Research. This is, I guess, for Brian primarily. You mentioned the risks. Could you say a little bit more about what the risks are that the companies you're referring to are talking about, and what is there something that it could be something that the public sector could do to mitigate some of those risks? What could be done to address that?
Well, I think some of it is the risk of the unknown. That there are things that can be done with data that folks can't even imagine. And the safest thing, if you're a company that's gathering information, I mean, obviously there are a lot of public questions right now about how a company uses its data. They're entirely appropriate. Now, that's a whole set of questions a company has to deal with. Now, the idea that a company would be struggling with those questions, as many are, and then would say, well, we have these other data that we don't really care about this that much, so we'll put it out in the back with the recycling. And if someone wants to come and use it, that'd be, sure, we don't care. Well, that's just a whole lot of trouble waiting to happen, right? And we don't know what the problems might be, but much safer to actually shred that data, if you will, so we don't have to worry about it anymore. And so that we're being responsible actors with those data as we struggle with the data that we're trying to use ourselves as a company. What the public sector does in that realm, I haven't seen good answers to that. But it's a critical question that we ask. Is it? Obviously, there are a lot of public levers that are available. Is it an industry standards thing? I don't know. I don't know the answer, but it's the right question.
I was wondering whether there was part of it was liability issues of some kind, and whether there could be some kind of liability protections that would shield companies if they're providing something for public use or anything along those lines.
I'm now out of my depth officially, but absolute liability is absolutely a piece of it.
So when I was at OnStar, we definitely struggled with this whole issue a lot because the vehicle data belongs to you. And it'll be interesting to kind of see what happens as the new generation connected cars come out, whether you're gonna, push the button that says I accept when you get your key, because it is definitely a change that's happening here. And now these vehicles are connected and they are collecting your information into the cloud, if you've agreed to do so. And now the OEMs have ownership of that data. So, things are, that privacy issue is moving around now. And, at OnStar, for example, we had to have a warrant to track somebody. And now, because of our new generation of Facebook people and, WhatsApp and all of those things, we're giving away our information to these third parties. So I think there's a struggle in this space right now that is going to come to bear at some point. I think one of the things, the solutions to these things is something that can be done by working with companies to say, we'll do some of our research behind your firewall. Or, for example, at Lawrence Berkeley Labs, I'm working with another company to say, we are secure, very secure vault for you, so we can keep your data safe and make it available for researchers without allowing it to get on a floppy disk. You're dating yourself there. But to make sure that it can't get out into the public domain. So I think there are solutions. We just need to start working that. Now I'll put the caveat back on it, is I don't want all their data, right? Stop collecting all that data. Collect what we need, not what you can. And so that's also part of it because it's expensive.
I think we have time probably for one last question, so we finished right on time.
Thank you for your time. Rob Hager with KPMG. I was interested to get your feedback on the Waze partnership they have with multiple governments. I believe it's called the Connected Citizens Program, where Waze is sharing user data with governments who, I don't know the parameters, but they may be able to use them however they see fit. Do you think that's an effective model?
That one I will probably take because Berkeley has a very aggressive effort on it. In fact, there is a policy brief that will come out of this effort on this very specific topic. So there's really two aspects to the Waze partnerships. I think it's really great to see public-private partnerships in which you have data exchanges. In the present case, the exchange is essentially traffic information for crowdsourced incident data. And that's great because you could look at that exchange in a way that none of the parties would have access to that data if the other was not involved. That's great. Nevertheless, when you look at the impact that companies like the one you just mentioned, now I'm talking generally, not just about this company, have on traffic patterns, way beyond, in fact, what Alexey showed, the real data that would be valuable to share is demand data. Alexey showed outstanding examples of what you can do specific to events like the sport event that he mentioned. Cities today don't have a way to see the city's jurisdictions, like all kinds of levels of geography, don't have a way to see immediate demand that is coming their way and how to change the signals that process their traffic. So I view it as an extremely good first step towards fixing that problem. But the real gain and the real win will be in the next step when actual demand data can be shared in real time. That's much more complex because the architecture for that is hard, and of course all the issues we heard about privacy is hard.
Can I add to that too? Is that back to the big data stuff? Is that every provider has a bias because they have devices out there and they are a sample of what's happening out there. So Waze I shouldn't use that, providers like Waze, have a great density of probe data devices out there in the Bay Area, but they may not in another city. And so what you get a very biased view of what actually is demand. So that's why we really need to broker many of these so that we're getting full population understanding as opposed to just whoever they happen to have out on the roadway at that time.
So we're reaching the end of the hour. I want to again thank all of you for coming to the UC Center here in Sacramento for this event, for this forum. We are going to have 2 more forums for this, organized by the 2 other branches of the ITS. So Davis and UCLA will be next. We're very excited to see a lot of people from public agencies engage in this. This is really what we're here for. Our mission to the state is really dear to our heart. And so following the questions and following the panels, we will stay around for at least another hour or whatever is needed to answer any questions you have. And we really look forward to working together in the future. Thank you all again for coming.